Uh, Welcome to my next installment of my video lecture series for the Principles of Microeconomics. And in this one I'm going to go over a numeric example of utility maximization. And what you see before you is a table that lists out different consumption combinations of beer and pizza. And above you can see I also have listed out how much beer costs. So beer is $4 a bottle. Pizza is $2 a slice, and the individual here in question has $20 to spend. So this is important information you need in order to determine what a utility maximizing combination of goods are. Also on this table you notice that I have, for example, the quantity of beer, and I also have the total utility for each of those totals of beer that are being consumed. So when I consume 0 beers, obviously I derive 0 units of utility from consuming beer. If I increase my consumption to 1 beer, I get 20 units of utility in total from 1 beer. I drink the second beer, now I have total utility of 36, so 2 beers gives me 36 units of utility, 3 beers gives me 48, and so on. I have the same information on the right hand side here for pizza. I have the quantity of pizza and the total utility of pizza, and I just list out different quantities of pizza that can be consumed and the total utilities associated with that level of pizza consumption. So at 0, once again, you get 0 units of total utility for pizza. I consume 1 pizza, or the individual consumes 1 pizza, and that generates 12 units of utility. 2 pizzas generates 22 units of utility, and so on. So number one, I want you to be aware of the difference between total utility and marginal utility. Total utility is the amount of utility generated from the consumption of those units. For example, if I consume 6 beers, I generate 62 units of utility from that total of 6 beers that are being consumed. Same thing for pizza. If I take a look at here, if I consume 4 pizzas, those 4 pizzas generate 36 units of utility. So it's giving me the total amount of utility I'm generating from the consumption of those 4 pizzas. Marginal utility, on the other hand, is the utility that's generated by the consumption of 1 additional unit. So thinking, for example, let me give you an example here. When I consume 0 beers, I generate 0 units of total utility. When I consume 1 additional beer, my total utility increases to 20. So this first beer is generating 20 units of total utility. Let's take a look at the second one. If I decide that I want to consume more than 1 beer, I want to consume a second beer, you can see that my total utility goes from 20 to 36. So this tells me that that second beer is generating 16 units of marginal utility. So let me go through and fill out this table here. So when I go from 1 beer to 2 beers, my total utility goes from 20 to 36. My total utility has increased by 16 units. When I consume 2 beers, I generate 36 units of utility. When I consume the third beer, my total utility goes up to 48. My marginal utility from that third beer is 12. So that third beer is generating 12 units of utility. If I decide to consume an additional beer, so originally I was consuming 3, and that was generating 48 units of total utility. I move up, and now I'm consuming 4 units, and that 4 total units gives me 56 units of utility. So my utility from the consumption of the 4th beer has gone from 48 to 56. That's an 8 unit increase in utility. If I move from when I'm consuming 4 beers and generating 56 units of utility, and I go to where I'm consuming 5 beers and 60 units of total utility, I see that my total utility increased from 56 to 60. My marginal utility is equal to 4, and for the 6th one, the marginal utility is equal to 2. I do the same thing for pizza. One thing that you should note here is that for the first consumption of a particular unit, take a look at beer. You'll notice that the marginal utility, the total utility and the marginal utility are equal to one another. That's not the case for the consumption past that first unit. So you can see the same thing holds for pizza. So when the quantity equals 1, total utility and marginal utility are equal to one another. So let's go from consuming one pizza to 2 slices of pizza, and we can see that my total utility goes from 12 to 22, so that increase is equal to 10. If I go from 2 to 3 pizzas, I see my total utility goes from 22 to 38. That means that third slice of pizza is generating 8 units of utility. So you can see here that what total utility is just the increase, marginal utility is just the increase in total utility that is caused by the increase in consumption by 1 unit. So every single time I increase my consumption by 1 unit, marginal utility is how much my total utility goes up. So for 4 slices of pizza, that's equal to 6. 5 slices of pizza is equal to 4. And for 6 slices of pizza is equal to 2, because when I was consuming 5, my total utility was equal to 40. When I consumed the 6th slice of pizza, my total utility went up from 40 to 42, so on the margin it increased by 2 units. So make sure you're comfortable calculating marginal utility from total utility. Next in this table, what we're going to calculate is the marginal utility of a particular item divided by the price. And we're standardizing how much utility is being generated on the margin for every additional dollar that we are spending. So for the first quantity, it's undefined. You can just leave that blank if you like. All you need to do here is take this column and divide by the price. So the price of beer is equal to 4 units. 20 divided by 4 is equal to 5. 16 divided by 4 is equal to 3. 12 divided by 4, 16 divided by 4 is equal to 4. 12 divided by 4 is equal to 3. 8 divided by 4 is equal to 2. 4 divided by 4 is equal to 1, and 2 divided by 4 is equal to 0.5. Do the same thing for pizza, and once again, when the quantity is equal to 0, we're dividing marginal utility divided by the price, so it's really undefined. So here we have marginal utility is equal to 12. The price of pizza is equal to 2, so it's 12 divided by 2 is equal to 6. 10 divided by 2 is equal to 5. 8 divided by 2 is equal to 4. 6 divided by 2 is equal to 3. 2 divided by 4 is equal to 2. And 2 divided by 2 is equal to 1. So we filled out that table. And now what we want to do is we want to select the combination of beer and pizza that maximizes our utility, given the fact that we are constrained by how much money we can spend. This is referred to as constrained maximization. Our constraint is we have a limited amount of money with which to spend. We're going out to eat, all we have is $20 to spend, so we want to generate as much utility as we can, given the fact that all we have is $20 to spend. In order to get the utility maximizing amount, what you need to do is pick combinations of beer and pizza that hold to the principle of equal marginal utilities per dollar. That means that the marginal utility of beer divided by the price of beer is equal to the marginal utility of pizza over the price of pizza. What that means is we want combinations of beer and pizza where these are equal to one another. Let me give you an example. There's going to be several examples. For example, that combination, and let me actually highlight that for you. Let me pick a shading. That combination and this combination right here, the margin utilities per dollar are equal to one another. Every dollar spent generates 5 units of utility. So the combination of 1 beer and 2 pizzas, the principle of equal marginal utilities hold. But what you will notice is there are going to be multiples where this holds. For example, color of that. This combination here, 2 beers and 3 pizzas, the marginal utilities per dollar are equal to one another. They're both equal to 4. And as you can keep going down, you will see that there are even more where the combinations of beer and pizza, the marginal utilities per dollar, are the same. 3 beers and 4 slices of pizza. We see that the marginal utility per dollar is equal to 3 for beer, and it's also equal to 3 for pizza. So we can keep going down, and we can see that once again there is another combination of beer and pizza where the principle of equal marginal utilities per dollar hold. Here, 4 beers and 5 pizzas. The marginal utilities per dollar for beer is 2, and the marginal utility per dollar for pizza is also equal to 2, and we can also see that there's one final one. Let me make that a different color. So you can see that there are multiples of where this principle of equal marginal utilities per dollar hold for one another. So this is where the constraint comes in. We want to pick the combination where the marginal utilities per dollar are equal to one another, and we are spending the $20. So let's take a look at those different combinations and see how much money we're spending. I noticed that this combination here, 1 beer and 2 pizzas, the principle of equal marginal utilities per dollar holds. How much money are we spending? Well, we're buying 1 pizza for $4 a piece, so we're spending $4 total. We're buying 1 beer and they're $4 a piece, so that's $4 that we're spending on beer. And we're buying 2 slices of pizza, which cost $2 a piece. We're also spending $4 on pizza. So we're spending $4 on beer, 4 on pizza, we're spending $8. So for this, remember that what we want to do is we want to spend all of our money. There's no savings. We're not saying that we're saving any money, that we are going to spend the entire amount of income that we have. So here, we are not spending all of our income, that red combination of beer and pizza. Let's go to the orange one. So we're going to buy 2 beers at $4 a piece, so we spend $8 on beer, and we're going to buy 3 slices of pizza. That's $2 a piece. That's $6. 8 and 6 is 14. So we still have some money left over. We have $6 left over. Let's go to the next combination, the yellow combination. So if we buy 3 beers at $4 a piece, that's $12. And if we buy 4 slices of pizza at $2 a piece, that's 8. 12 and 8 is 20. So this yellow combination here of 3 beers and 4 pizzas, we are spending the entire $20, and the principle of equal marginal utilities per dollar holds. Let's go past that and see if we can get higher levels of utility. Let's go to, I guess, light green would be the best way to describe that color. So that would be 4 beers and 5 pizzas. If we buy 4 beers at $4 a piece, that's $16. And if we buy 10 slices of pizza at $2 a piece, that's $10. That's $26. So yes, the utility from 4 beers and 5 pizzas is higher than the previous combination of 3 beers and 4 pizzas, but we can't afford to buy that. We can't afford to buy 4 beers and 5 pizzas. That's $26. That's $6 more than our income allows us to buy. So the combination that maximizes our utility is the yellow one right here. And let me actually just get rid of all those, make it easier for everybody to see. Sorry for the delay there, but the yellow combination is the answer to this question. That is the combination of beer and pizza that we can afford to purchase and that maximizes utility. So this individual, if their goal was to maximize utility, given this table about their preferences between beer and pizza, would buy 3 beers and 4 pizzas, and they would generate 48 units of utility from beer, 36 units of utility from pizza for a total of 84 units of utility. So let me actually put that on here as a reference. All right. Well, let me pick some other combinations to illustrate to you that this is the case. Let's pick another combination of beer and pizza where we spend $20 and compare that to the 84 units of utility when we purchase 4 beers. Let me put that in there. QB equals 3, and QP equals 4, giving us 84 units of utility. Let me actually subscript those. So that is their answer. 3 beers, 4 pizzas, 84 units of utility. Let's pick another combination where we spend $20, but then let's determine what our utility level is. For example, could I not buy 5 beers and not eat any pizza? If I spend if I buy 5 beers at $4 a piece and no pizza, I'm spending all of my income. What's the utility associated with the consumption of 5 beers and 0 pizzas? It's equal to 60. So I am on that budget constraint, when we talked about that previously. So we're on the same budget constraint as 3 beers and 4 pizzas, but what's the difference? I'm only getting 60 units of utility from those 5 beers versus the 84 units of utility from 3 beers and 4 pizzas. All right, so let's pick another combination to say if that principle of equal marginal utilities per dollar actually gives us the highest level of utility, if it actually maximizes our utility. Let's buy, for example, 4 beers. Let me actually highlight that. Let me pick blue. I guess that's okay. So if I buy 4 beers, that's 16, I have $4 left over, which means I can buy 2 slices of pizza. So I can get 4 beers and 2 slices of pizza and spend my $20. What's the total utility for the consumption of 4 beers and 2 pizzas? 56 plus 22 gives me 78. So that combination doesn't maximize utility. All right, so you can go through multiple combinations of this. All right, so let me pick another combination. Let's say I decide that if I want to spend all $20, I buy 2 beers on $8, which leaves me with $12 left. I can buy 2 slices of pizza. So on the budget constraint, I'm spending exactly $20. How much total utility do I generate from 2 beers? 36. How much total utility do I generate from 6 slices of pizza? 42. 36 plus 42 is 78. Once again, that is less utility than the utility maximizing combination. So what I did there was I just gave you several different points that lie on the budget constraint but do not maximize utility. So I was illustrating to you that principle of equal margin utilities per dollar, where this equals this for the 2 commodities that I'm talking about, that is the utility maximizing condition. What is our constraint? Our constraint is always going to be how much money do we have to spend, and what do we need to know in order to do that? We need to know the price of the 2 commodities. So any 2 commodities that I give you, I'm going to have to tell you the price. But I'm also going to have to tell you how much money do you have to spend for that. That's the constraint. That gives us our budget constraint. It shows us what's the most that we can purchase of all those, of the 2 commodities that we talked about. It gives us all those combinations. So hopefully this was of some help. If you still have some issues with this, make sure you ask questions in class or you come and see me during my office hours.